Greetings, my fellow Omontians, and welcome back to another broadcast from the bunker. Today's hot topic, rates of weathering. How do we describe the factors that affect the rate of weathering? Pretty cool stuff. Makes some gorgeous landscapes, as you'll see. All right, let's get started out with the do now. Numbers 29 to 31. So spend a few minutes on those, and we'll be right back. Okay, I'm going to start out with this diagram here. If you look closely, this is a polar view of the Earth. Some people call it a top view, but there is no top of the Earth, right? Polar view because that's the North Pole right there, which makes this circumference the equator. And from the polar view, we're going to get a counterclockwise motion, right? So the shaded area is night, the lit area is day. This would be when night goes into day, right? That's your sunrise point. And day going into night, that's your sunset point. Now notice how the Arctic Circle is completely cut in half, right? 50-50 dark light. Well, that means it's got to be one of those equinox days. Because those are the only 2 days where you get the light perfectly cut in half through the Arctic Circle there. So let's take a look at the first question. All right. It says the time at point C is closest to. Well, let's go to point C here. And if you take a look, we said it's going to rotate counterclockwise from the North Pole view. So C is just about to go into night. So that's got to be around a 6 p.m., right around a sunset. And on equinox day, that would be about 6 p.m. So let's see what the options are. And there you have it, about 6 p.m., right? Just about going into sunset. Okay. 31 says the diagram, 30. Which day of the year is represented by this diagram? Well, again, that's that whole 50-50 split in the Arctic Circle. So if it's perfectly cut right that, it's got to be one of the equinox days, which would be either March 21st, right, plus or minus a day, or September 22nd or so, plus or minus a day. Let's see what it offers. And it's offering the March one, right, March 21st, a.k.a. the vernal equinox. All right, so circle that in there. Some people call that the spring equinox. All right, and our last one for today is the classic Earth orbiting the Sun diagram. It wants to know at which position is the Earth located on December 21st. So that would be the winter solstice. Well, the North Pole's got to be tilted away from the Sun. So here we're towards, here we're kind of parallel, and that one's away. So that certainly is December 21st. Plus, look at the distance between the Sun and the Earth, right? It's the closest. We call that crazy sounding word, remember? Perihelion. So that's your perihelion. This would be your aphelion. All right? So circle it in there, position C. Maybe label that as well. Okay. Okay. Again, any questions on that, post them in the comment section below or shoot me a reminder. Let's jump into the lesson. Okay. Once again, folks, thank you for your continued persistent and patience with the internet issues, making it challenging to complete assignments. I understand the frustrations. I'm still waiting on some of you guys to submit some work, but a lot of you guys are giving me some really nice stuff, so I appreciate that. All right, take a look at these two pictures on the bottom. This you could clearly see they're wearing away at different rates, right? Some more rock is worn here, less rock here. Same thing over here. You have a lot more rock up top. It's worn down below. Well, what's going on there, right? Why are we getting these different rates of weathering? Okay. Look at this beautiful picture. I mean, how does something like that get created? It's absolutely gorgeous. It's out in Utah. Again, you could see that, certain rock seems to be wearing at different rates. Leaves this gorgeous sculpture. But how does it happen? All right. Little background information for you. Please read that through. All right. I will start out a couple of quickie notes, and then I got a little thing to show you here. So, rate of weathering depends on a few things. Well, first off, the surface area and the particle size. Take a look at the top right here. This is a solid cube. And because it's solid, it's quite large, weather can't get to the inside of it. It has a low surface area, so it's going to weather very slowly. But as it breaks down over time into smaller chunks, you increase the surface area. Now more rain can get in there, more wind can attack these things, and they break down even smaller. And the smaller they break down, again, the more wind and rain can hit them, the faster they weather, and the rate increases. So surface area is a big part of that. All right. Next thing, of course, we talked about the other day, climate. If you're a hot climate, a lot of moisture, you tend to have a quicker rate of weathering as well. And mineral composition, right? What it's made out of. Different minerals have different resistances to being broken down. And that all affects this rate of weathering and creates these beautiful landscapes. Okay. Little experiment I'd like you to try at home. Get 2 cups and 2 Alka-Seltzer tablets. Very simple. Just you're going to drop one in solid, and then you're going to crush one up and put it in there. And be ready on a timer and see which one will dissolve faster. Obviously, the one you break apart is going to have a higher surface area. So try that out right now. Okay. You're going to put them right on in and see what happens. Watch this little clip. Hopefully your experiment looked something like this.
Set, go.
Oops. Gotta go back there. There we go.
Okay, ready, set, go.
All right, there's your solid tablet. That was your crushed up tablet. Much greater surface area here, much less surface area there. Look at the difference it takes to dissolve. And this is, an analogy of how quickly it would break down. More surface area already broke down. Less surface area takes more time. All right? Slower rate, faster rate. Okay. Hopefully that made some sense to you. All right, how does the particle size and surface area affect the rate of weathering? Well, like we said, if you break something down, you make the particles smaller, they have a higher surface area, it's going to weather much faster. So make sure you get that into your notes. Climate also a huge factor here, right? We said the more moisture there is, the faster weathering you're going to get. And as rock gets cracks in it over time, it'll weather faster. Same thing with statues and sculptures. The more cracks they get, the faster they'll weather. So you have to reseal them to make them last longer. Okay, there you have classic frost action, right? As the water freezes, it expands, it pushes the rock further apart. Okay, so climate a huge factor, right? Warm, moist climates, you're going to have more chemical weathering. Whereas cold climates that still have moisture, you're going to get a little more frost action. And it's even faster if the temperature goes above and below freezing more frequently. All right. Here's a graph down here. Everybody with your hands. What does this graph look like, right? The more rain, what will that do to chemical weathering? Well, hopefully you did one of these. And there it is. Okay. Here's a great chart. Combines 2 different variables here. You have temperature on the x-axis. You have precipitation on the y. For the first section here, if you want strong frost action, well, look, you got to be cold, but you have to have a decent amount of rain. Okay? If you want moderate chemical weathering with frost action, well, you got to be a little warmer and have a little more rain. And then for strong chemical weathering, well, you got to be much, much, much warmer and get a lot more rain, like in a tropical rainforest. Okay, the tropics is mostly chemical weathering, not much physical at all. All right, see if you can relate this diagram here to a couple of questions. Identify the type of weathering that takes place at a temperature of 20 degrees and a precipitation of 100. Well, slide over, put your finger on 20 degrees and a precipitation of 100, and what do you got? Well, you should have moderate chemical weathering. Next one down, identify the type of weathering at a temperature of -5, that's all the way down here, and a precipitation of 25, so you are right here, and hopefully you're in slight frost action. Okay? Check this out. These kids died in 1500 AD. They're Inca children. The Incas used to sacrifice children to appease the gods. They lived in a volcanic area, right? The Andes down in South America, which, by the way, is where andesite comes from, right? Your igneous table there. Anyway, these kids, they are, of course, deceased at this point, but they look very, very pristine as far as weathering goes. Well, how is that possible? Where on this chart would you have extremely, extremely slow rate of weathering? Well, you'd have to be very, 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 very dry and very, 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 very cold. And up in the Andes Mountains, of course, it is dry and cold. They were kept in sheltered areas. They weren't exposed to the wind and the rain. It was mostly below freezing, so they were preserved amazingly well. Okay? All right. How is the mineral composition found in rocks affected by weathering? Well, which rock type is most resistant? If you're resistant, that means you don't weather much. So look at these rock types here, A, B, C, and D. Which one has weathered the least? Well, that's going to be the one that's sticking out the most, right? And there it is, A. A is a limestone, which is interesting because limestone, as you know, made of calcite, weathers quickly as far as chemical weathering. But it is kind of tough and resistant to wind and abrasion, so physical weathering is quite resistant, and that's what's going on there. Which one is the least resistant? Well, that's the one that's worn down the most, and that, of course, would be B. Now, look at the symbol. B is a shale. Shale, if you recall, is made of clay. Clay is very soft. It is not resistant. It will weather very quickly. All right. These are actual pictures of the rocks, right? Limestone, much harder solidified there, whereas shale tends to be, breaks in layers, very friable. Okay. A couple more notes for you, right? Make sure you get them in there as far as how these different things here affect weathering. Harder minerals are more resistant. Softer minerals are less resistant. All right, make sure you get that into your notes. All right. And then we get down to soil, right? We certainly couldn't survive without soil. That's how we grow all our crops. Well, you start out with a solid rock. And over time, weathering and erosion breaks it down. And initially, you'll have this mix of, big particles, not much organic matter. It's just broken down rock. And then as time goes on, living things will die. It'll get mixed in there. You get richer, more organic. Finally, you get this perfect mixture of the minerals from the rocks, and all sorts of nutrients from the once living things, and you get this dark, rich soil over time. And they call those soils, and the different layers are called horizons. All right, so make sure you get that into your notes there. All right, a couple summary questions. Which rock layer is the most resistant? Remember, that's the one that's going to be weathered the least. So the one sticking out the most, you got to go with 3. Now, this diagram is interesting because it's actually a profile of a waterfall where the water has stopped flowing. So the water comes over the edge and it bangs and it bangs and it bangs. And the softer ones get worn away faster, whereas the harder ones stick out. So maybe draw a little waterfall in there if you can. And there it goes, down, down, bang, bang, bang. And the one that, and of course the river then would just keep flowing. And the one that weathered the least is the one sticking out the most. That would be the most resistant to weathering, which incidentally is a limestone once again. Which one of these would break down faster? Well, The faster one has a greater surface area, so you break it into smaller pieces, certainly you'll have a greater surface area. Okay? All right. So there it is, folks. Hopefully you followed that. Remember, any questions, please post them down in the YouTube comment section, or certainly remind me at that code there. All right? Take care.